Welcome to the another video of the power electronics converter. In this video, we discuss about the discontinuous conduction mode with constant VD. That means that we are assuming that the supply voltage is given through a battery and the supply voltage is constant. Now we are working with this is a load resistance R. Now this resistance is like if it is heavily loaded, then it will draw more current through this and you have a current I0. And if it is now gradually the load is decreased. So when you say high loading, then we have a low value of R is less. Then is light load. When we say light load, we are actually increasing the value of R. So if you increase the value of R, so what will happen? It will leads to decrease in the value of the current and decrease in the value of the average current, and that will lead to decrease in the value of the inductor current. So now the inductor current will no longer be continuous, rather it will be discontinuous. So we have also assumed that in the boundary condition we have calculated for a boundary value what is the value of ILB. So like if the current would have been like this and you have this would have been a current till the boundary it completes. If the current would have been there, so we'll have minus V0 till that time. But since the current is not up to the end of the off period, rather the current is up to certain time which is not known, let us say some value, and after that again you have got same pattern will repeat. So here you have up to this is the, if I say total time is here to here, where we call it TS, switching to interval, and this is your on time, so this is DTS, and the time during which this is decreasing, let us say this time is equals to del 1 TS, and the time during which it is off, let us say it is del 2 TS. So in this way we split the time duration, and the del 1 is the time during which it is turned off. Now what happens when the load is reduced? Load reduced means the resistance is increased, so indirectly resistance is increased, obviously the V0 will increase. So you have got a minus V0 which is reflected in the VL will obviously increase. That leads to have a discontinuous current, so the value of IL is now discontinuous over here. So here at this particular point we have VD minus V0, and this current is rising up to the value of this maximum value. That value we can say this is del IL also, because that is the total ripple, and also this is IL peak value. So for the boundary condition we can write like this value is ILB, the boundary value is that VDTS by 2L D into 1 minus D. Also we can write this in terms of maximum value. Maximum value is ILB max is equals to VDTS by 8L, and we can write this ILB in terms of maximum value as 4 ILB max D times of 1 minus D. Now for this particular case, when it is on for DTS and it is off in del 1 T, so if we equate that like energies stored and energy released by the inductor should be same, we can use this formula that VL is equal to L di by dt. We can use this formula and we can get the expression what is the value of the del I, because del I is same for both, and we can write this is as Vd minus V0 into dTs by L is equals to it is dTs is the time during which it is on, that's why dTs. Also we can write it for the off time. So when you write it for the off time, so del I remains the same, only the dt will be del 1 ts and the voltage is minus of V0, so that value is V0 here, because del I will be negative, so that's why we will write V0 divided by L. So this LL cancel out. Now what remains is, so we rewrite this expression again like this. So here V0 term we can take common, so here Vd into d, ts is cancel out in all, this is V0 d plus del 1. So we can write here V0 by Vd is equals to d by d plus del 1. So what is the thing is that Vd is constant and V0 by Vd will give you this relation. Now in this if I want to find what is the average current, so average current will be, this will be like average value of the current. So this average value of the current will be, let us say, I0. So I can write this I0 as what is the average value of this current will be. This is a triangle. So if we can write this triangle as we know, half base into height. So using this type of formula, we can write this what is the average. So we can write I0 is equals to half, what is the base? Base value is dTs plus delta 1 ts, that is a total base, and the height is total is equals to IL peak. So some value is there, so we can write here that this is the highest is IL peak, and that is, this side is the area and this side also multiply with ts. So we can cancel the ts and we can write I0 is equal to half d plus del 1 into IL peak. IL peak is nothing but del I total value. So we can substitute the value of del I here. So from here we have taken del I value is del 1 ts V0 by L. We substitute that and that will give us a value that is V0 ts by 2L del 1 d plus del 1. We get the value of I0 like this. Now we need to convert this V0 term in terms of Vd. We can also convert and we can get the value of del 1. So if I convert V0, V0 into d plus del 1 is equal to Vd into d. From this expression we can get the value of, from V0 del plus del 1 will be equals to d into Vd. So let us write here I0 is equals to Vd ts by 2L into del 1, and d is also multiplied here because d times of Vd. So we get the value of I0 here, and also we have got the value of I0 that ILV max. What is at the boundary condition, what is the value of ILV max? That is Vd ts by 8L. So if we substitute over here, this will be 4 ILV max into del 1 and D is equal to I0. So from this we can write that del 1 is equals to I0 by 4 ILB max into capital D. So this is the expression for the del 1 we obtained. So now what we can do is this expression of del 1 we can substitute here, and we can write again this expression as this del 1 we will substitute here directly and get the value of V0 by Vd. So this is the value of V0 by Vd, and putting the value of here del 1 we get here D by D plus I0 by 4 ILB max into D here. D is the lower end. So we can rewrite this taking D here square and square term, D square by D square plus I0 by 4 ILB max. So this expression will be equals to V0 by Vd. So here we are getting an expression where we can say that here if I0 by ILB max, this is going to vary. ILB max is constant, so I0 is going to vary. If load is going to vary, how does the V0 is going to behave for a particular value of duty cycle? So we can see say this equation will look like y is equal to 1 by 1 plus x. We can get this type of things, or c square by c square plus x. So if x varies, then how does this will vary? So we can take this 1 by 4 out also. It's the same thing. Like if we just only take this instead of writing 4 over here, we can write 1 by 4. So we can say like x by 4, and y is here nothing but V0. So how does the equation curve will behave? So now we have this curve going to draw. Going to draw the curve here. So when d is equal to 1, when d is equal to 1 is like d is what? T on by t, right? T is switching interval. So if like d is full 1, so t is on means there is nothing to say. We will say the output voltage will be equal to the input voltage throughout the load. How the output voltage will never change, because here is the Vd plus minus, and we are just keeping the switch on, and we are getting here is the V0. So our V0 by Vd will be constant, and let us say this is 1. Then again, if the value of d is 0.9, this line would be, there was a small curve over here, then it will be a straight line. So similarly, we'll have for different value of d, will have the curve getting sloped downward, and then we'll have a straight line like this. We'll have a curve and a straight line like this. So here we have different values of d is equal to 1, 0.9, 0.7, here it is 0.1 or 0.3, like this. So from all these we are getting a dotted line here. Dotted line means a range in which the current range in which this is a current I0. If the load is more, obviously the current is continuous, and you get a value of V0 by Vd nearly constant. In case of discontinuity, there is if suppose at this particular point for d is equal to 0.7, so up beyond this value of I0, so let us say this is the higher range is nearly to 1.0. This is coming around to be 1.0. This is 0.5, and let us say this is 1.5 and this is 2. So up to this value of nearly 1, and you'll have a discontinuous beyond it. That means if the I0 is exceeding the value of ILB max, it is in continuous mode. And as long as it is, this will be just touching maximum is up to 1. So if it is below the ILB max, that is 1 per unit, that is in terms of per unit it is 1. If it is below 1, then it is discontinuous. If we take some value of D, let us say this value would have come like this, and this here what we get is another value of D, and this D value should be 0.5, because when you write D equals to 0.5, that is also 1 by 2, 1 by 4, 1 by 4, 1 by 4. All for 1 by 4 will cancel. We will get a pure equation as 1 by 1 plus x. So when x is equal to 1, you will have V0 is 0.5. So this value is nothing but 0 is 0.5, because when x is equal to 1 means I0 is equal to ILB. This is just half. So like that, this side will be denoting your discontinuous mode, and other side will be called as continuous mode. So for a fixed value of VD, so VD is maintained fixed. In this case, this is the situation.